Welcome back to The Explainer. Today, we're jumping right into one of the most intense, massive, and honestly consequential physical tensions on planet Earth right now. We're talking about the clash between mineral extraction and environmental preservation. Look, our modern world absolutely relies on extracted metals and minerals, but pulling them out of the ground puts just profound stress on some of the world's most delicate ecosystems. So in this explainer, we're going to look really closely at the rigorous sustainability accounting standards that measure exactly how the mining industry interacts with Mother Nature. Okay, let's dive into our roadmap for today. 1. Mining versus Mother Nature. 2. The ecological impact life cycle. 3. Acid rock drainage explained. 4. Endangered species and protected sites. And 5. Measuring corporate accountability.
Section 1. Mining versus Mother Nature.
So, here is the massive question we really need to unpack today. It's the central tension of this whole explainer. How exactly does the world balance the skyrocketing demand for extracted metals with the absolute necessity of protecting delicate ecosystems? Think about it for a second. Every single smartphone, electric vehicle, and skyscraper requires raw materials pulled straight from the earth. But those materials don't just sit in empty voids waiting for us, right? They are buried directly beneath forests, wetlands, and vital habitats.
Consider what is actually at stake here. On one side, we have the incredibly heavy industrial reality of extraction. That means identifying reserves, tearing into intense site development, and managing long-term production. On the other side, we have conservation, maintaining pristine ecosystems, protecting wildlife habitats, and ensuring water quality isn't destroyed. Navigating the friction between these two massive forces is exactly where environmental management becomes absolutely critical.
Moving right along to Section 2, the ecological impact life cycle.
You know, a mine isn't just some hole in the ground that exists in a vacuum. It has a very distinct chronological life cycle, and ecological risk is present at every single stage of that journey. It actually starts before a shovel even hits the dirt, during the pre-bid and exploration phase. Then we move into site development, which is followed by decades of active production. But notice how the timeline doesn't just abruptly end when the mining stops. The closure, decommissioning, and restoration phases stretch decades into the future, and they are just as critical. Environmental risk doesn't simply vanish the second the metal stops flowing.
And this is exactly where the accounting standards step in. SASB metric EM/MM 168.1 essentially mandates that companies detail their environmental management policies for active sites. Having a highly effective environmental plan for every single stage of that life cycle we just looked at is totally non-negotiable. Why? Well, because actively managing ecological and biodiversity impacts, handling waste, and controlling emissions early on dramatically minimizes compliance costs and massive legal liabilities down the road. It's all about foresight.
Section 3. Acid rock drainage explained. Let's talk about acid rock drainage, or ARD. Guys, this is essentially a toxic ticking clock. ARD occurs when surface water or shallow groundwater comes into direct contact with the rock and overburden that was moved around during mining. This chemical interaction contaminates the water with heavy metals and makes it highly acidic. It's a slow-moving, totally devastating chemical reaction that can poison local water supplies and severely harm human populations, local animals, and all the surrounding vegetation.
So, the crucial point here is that investors and regulators need to know exactly where this toxic ticking clock is ticking. Under SASB standard EM/MM60A.2, companies can't just vaguely mention ARD and move on. They are forced to specifically track and report the percentage of their mine sites in 3 distinct phases. First, sites where ARD is predicted to occur based on chemical evaluations. Second, sites where it's being actively mitigated, like by sealing the mine or mixing in acid buffering materials. And third, sites where the water is currently captured and under active treatment or remediation. It basically forces absolute transparency on a massive environmental hazard.
Section 4. Endangered species and protected sites.
Mining companies often find that the metals they desperately need are buried directly beneath protected, highly sensitive lands. But protected isn't just some casual buzzword here. It refers to strict international conservation designations. We're talking about IUCN protected areas, Ramsar wetlands of international importance, UNESCO World Heritage Sites, Natura 2000 sites, and biosphere reserves. To even consider operating near these zones, companies face immense scrutiny. And rightly so, because these areas are recognized globally for their incredibly high biodiversity value and as habitats for endangered species. To put a hard number on that exact risk, SASB metric EMM 168.3 requires entities to disclose the precise percentage, both by weight and by grade of metal content, of their proved and probable reserves sitting in or near these sensitive zones, and near is explicitly defined as within 5 kilometers. This metric is huge because it completely removes the guesswork. It tells everyone exactly how much of a company's future revenue is tangled up in the world's most fiercely protected ecosystems.
Let's explicitly translate that ecology directly into hard business economics. When a company's reserves are located in an endangered habitat, that ecosystem protection directly equates to higher extraction costs. It means facing massive regulatory barriers just to get a single permit. It means the company is taking on severe operational risks and huge future remediation liabilities. In the mining industry, Mother Nature's boundaries literally dictate economic reality.
Section 5, Measuring Corporate Accountability.
So how do we actually hold these companies accountable? Through standardizing the data. The International Sustainability Standards Board, or ISSB, assumed responsibility for the SASB standards and is fully committed to evolving them. This framework is what ensures companies aren't just making vague promises in a glossy corporate brochure. They actually have to use these specific metrics to put a concrete, fully auditable number on their relationship with Mother Nature.
Now, what's really interesting here is the sheer scale of the financial stakes involved. The source text explicitly warns that material costs may arise from removing or covering refuse piles, meeting water treatment obligations, and dismantling infrastructure at the end of life. Look, site reclamation is an enormous financial undertaking. A company has to restore the mine property according to a strict, pre-approved plan. If they don't properly account for these massive end-of-life costs while they're actively mining and making money, the financial fallout later on can be absolutely catastrophic.
We've covered the complex life cycle of a mine, the toxic, slow-moving threat of acid rock drainage, and the incredibly strict accounting required for endangered habitats. So I want to leave you with this final provocative thought. If a mining entity's reserves are entirely located within a protected biosphere, at what point do the staggering environmental liabilities, the immense compliance costs, and the looming risk of ecological disasters simply outweigh the value of the metals buried beneath the surface? It is a fascinating calculation, and honestly, one that will define the future of our modern world. Thanks so much for joining me on this explainer, and keep learning.